Okay, so let's look at the second problem on coagulation. This talks about tobacco smoke, and it says, by what factor does the average particle size of tobacco smoke increase due to coagulation during the 2 seconds? So we have a time. 2 seconds it takes for the smoke to travel from the cigarette to your lungs. Assume that the concentration leaving the cigarette is 3 × 10⁹ particles per cubic centimeter. So that's where we're starting, our initial number concentration. And the coagulation coefficient is 7 × 10⁻10 cubic centimeters per second. So we're looking for a factor, right? By what factor does the average particle size increase? So again, we're going to be looking at the size of the particles over time, which is this dt equals d naught n naught over nt to the 1/3. So we don't have the final number concentration. So what we're going to do is plug in for that final number concentration from this expression for it, or equation for it. So then d of t equals d naught. We have n naught over n naught, that'll cancel. And what's in the denominator here will come into the numerator. And then we have all of these values over time, coagulation coefficient, and initial number concentration. And we're looking for a factor, and so that factor will be the ratio of d of t to d naught. Since we don't have a size, right, we don't know if we need a beta factor or what it should be if we do need it. So we should just write over here that we're assuming that beta is approximately 1. And then we need to plug in the values that we have, and not the coagulation coefficient in our time. And if we plug all of those values in, then, right, we know even before we plug stuff in that this ratio has to be greater than or equal to 1, right? Or really strictly greater than 1 because our particles are getting bigger over time. So if we get anything less than 1, then something's gone wrong. It should be about 1.73.